Hi everyone. Some integration questions selected from past papers of NED. We have started almost from 2000 as well as 1919. I'm not sure, but I'm confirmed these questions have been taken from the paper of 2000. Without wasting time, let's solve them. Definite integral 0 to 1 over 1 plus x square dx. Making life simple, don't go in magic substitution. Ask yourself, is it differentiation of something? Yes. Yes, it is differentiation of tan inverse or arc x. Tan inverse or arc x. So its integration must be tan inverse x. Its integration is given by tan inverse x plus c, applying limits, upper limit minus lower limit. Here let me write the limit same, 0 to 1, upper limit minus lower limit. Instead of x, plug in the values 1 and 0, tan inverse of 1 plus c. This is upper limit minus overall function to be taken, that is tan inverse of 0 plus c. We are familiar in which angle value of tan is 1. In which angle value of tan is 1? That is definitely 45 or pi upon 4 plus c minus 0 minus c. C cancelled out. That is pi upon 4 is our answer. Same question is present with little variation. Here the limit must be 0 to infinity. 0 to infinity. Tan infinity prevails at x is equal to 90. X is equal to 90 or pi upon 2. You should have this thing in mind. Very famous question, notorious question in the field of integration for NED. Ask yourself, 1 over 1 plus x square is differentiation of something? Yes, differentiation of tan inverse x is 1 over 1 plus x square. So its integration is definitely tan inverse x. And we have done. So how to put limit? First upper limit, then lower limit. And lower limit must be less than or equal to upper limit. It is the rule. It is the rule. Moving towards question number 2. Moving towards question number 2. It is e raised x over 1 plus e raised 2x dx. Okay. Making life simple, don't go here and there. It's 1 square, it is r e raised x square. E raised x square dx. It is just differentiate tan inverse x. Tan inverse e raised x with respect to x. Its differentiation is given by 1 over 1 plus, instead of x, we have e raised x square times differentiation of this angle, that's ex. So we have ex over 1 plus e raised 2x. It is also the same case of tan inverse e raised x. Tan inverse e raised x. So our answer in that case is tan inverse e raised x plus c. Or one can utilize magic substitution here. Suppose y is equal to e raised x. Differentiate dy over dx. It is equal to e raised x, or dy is equal to e raised x times dx. Shift in that integral, we are going to have something dy over 1 plus y square. Instead of e raised x dx, I have introduced dy. Instead of e raised x square, e raised x, I have introduced y square same. Again, this is the same situation of the previous question, 1 over 1 plus x square. Its integration of, its differentiation of tan inverse y. It is differentiation of tan inverse y. So its integration is tan inverse y plus c. Re-put the value of y. That's e raised x plus c. And it's our answer in that case. And it's our answer first. Moving towards question number next. That is also substitution case when we suppose x is equal to a sin theta or x is equal to a cos theta. But without indulging in this, utilize this, a good one. Sine inverse x. What is differentiation of sine inverse x? It's 1 over 1 minus x square times differentiation of angle x. Differentiation of x is 1, it's 1. This is the case also here. Limits are 0 to 4. 0 to 4 sine, sorry, dx over 9 minus x square. Instead of 9, I can write, 3 square, x square. 0 to 4, 0 to 4. If we suppose x is equal to 3 sine theta, then differential x is going to be 3 times sine theta cos theta. Putting both these values here, and we are going to get something really very cool result. 3 cos theta instead of dx, it's our 3 square. Instead of x, I have 3 sine. So 3 square sine square is my magic substitution. Taking 3 square common, I am left with 1 minus sine square. If we take 3 square common, we are left with 1 minus sine square. 1 minus sine square is equal to cos square. 3 cos theta. Taking 3 square common, we have 1 minus sine square theta. It's d theta same. 1 minus sine square, it is equal to cos square. There is 3 square, cos square. Both are perfect square quantities. They must be out of the radical. 3 cos theta d theta. We have 3 square cos square. Square root cancelled out. We have something like, pass me the marker having ink. It's 3 cos theta d theta divided by 3 cos theta. Cancelled out. We are left with what d theta? Theta plus c. Reput the value of theta. Reput the value of theta from here. Theta is equal to sine inverse of x over 3. Sine inverse of x over 3. Utilize here. Sine inverse of x over 3 plus c. Putting upper and lower limit minus lower limit. We have something, sine inverse 4 over 3 plus c minus sine inverse 0 over 3 plus c. Sine 0 is 0, c cancelled out. We are left with sine inverse of 4 upon 3. Sine inverse of 4 upon 3 plus c. Our answer. Sine inverse of 4 upon 3 is our answer. In that case, we also suppose x is equal to 3 cos theta. We can also assume that x is equal to 3 cos theta. Both substitution works, but mostly sine theta is to be taken in such cases. Moving towards next question. It's simple one. Pass me the marker. Thank you. With lid. Yes. Next question is function derivative situation works. One of us a to b dx over x plus 3. Differentiation of x is 1. I used to write function having overall power 1 and function is the denominator. Function is in the denominator having overall power 1. Function in the denominator having overall power 1. It is the situation of ln. Differentiation in the numerator. Function is in the denominator having overall power 1. It is the famous case of ln whatever is present in denominator. So does the situation here. It's our ln x plus 3 plus c. Function derivative. Putting limit, upper limit minus lower limit. What is our upper limit? Ln. What is the upper limit in that case? A to b. A and b are mentioned here. A and b are minus 8 and minus 4, I think. Minus 8 and minus 4, if I'm not wrong. Okay. Ln. Instead of x, write upper limit minus 8. That's minus 4. What is lower limit? Lower limit is minus 8 and minus 4. That is minus 4. Because upper limit is always less than or equal to upper limit. Lower limit is always lesser than greater limit. Lower limit. Okay. Minus 8 plus 3 plus c. Upper limit minus lower limit ln minus 4 plus 3 plus c. We are left with ln negative 5 plus c. That is negative ln minus 1 plus c. Just multiply. I am going to have ln minus 5 plus c minus ln minus 1 minus c cancelled out. Applying tiny property of log from separate logs in subtraction, they can be written in division. Ln 5 negative 5 over minus 1. So we are left with ln 5 is our answer in that case. Ln 5 is our answer in that case. Ln 5. Final question for today's frame. X plus 8 dx divided by root x dx. We have to integrate this one as that is x plus 8 divided by root x dx. It is a famous case of synthetic division where we have to adopt synthetic division when numerator has greater degree than denominator. When degree of numerator is greater than denominator, or degrees of the numerator and denominator are equal. Either they have equal degrees or numerator has greater degree. Either they have equal degrees or numerator has greater degree. It is case of synthetic division simple. Dividing with root x each term. It is something 1 minus 1 upon 2. I am left with 1 over 2. Shift this root x in numerator. It will become negative 1 over 2 dx. Add 1 into the power. 1 upon 2 plus 1. It's 3 over 2. Dividing with the same. So does here. Minus 1 over 2 plus 1. It's our positive 1 over 2. Dividing with same. It will become 2 8 the 16. It will become 2 root 2 over 3 times x raised 3 over 2 plus 2 times 8 x raised 1 over 2 plus 3 or 2 over 3 x raised 3 over 2 plus 2 at the 16 x raised 1 over 2 can be written as under root x plus c plus c. So what is the answer in that case? This first one is our answer. It's my tiny effort to guide you integration based on past papers, especially selection from past papers of interest. It's all by itself. Next.